Hello everyone, welcome to video lecture series of radar systems. Today's topic is continuous wave radar, CW radar which is. In this video I am going to talk about the block diagram of a simple continuous wave radar and CW Doppler radar with IF amplification. Let us begin. To start with, see, we have already discussed about the pulse radar system. So continuous wave radar, which is the CW radar, this is opposite to the pulse radar. In case of the pulse radar system that transmits pulses, but here it continuously transmits the electromagnetic radiation. So there is a continuous transmission in the case of the CW radar. Continuous wave radar, it can measure the instantaneous rate of change of the target range. So this is the beauty of this, and this radar, it actually works on the principle of the Doppler shift, which is because of the motion of the target. And this particularly thing which we are going to calculate the target range, this is accomplished by direct measurement of the Doppler shift of the return signal. And what is Doppler shift? We have already discussed. Just you have to remember that the Doppler shift, it is a change in the frequency of electromagnetic wave caused by the motion of transmitter, target, or both the moving, right? So this is how you can compute it. So the radar which operates with continuous signal for detecting moving targets means the non-stationary targets, that is known as a continuous wave radar or simply CW radar. And CW radar, Doppler radar, which actually it is based on the Doppler frequency shift. It gives accurate measurement of relative velocities, and most of these things are used where information of velocity is very much important, even in comparison to the radar range also. This is a simple block diagram of a continuous wave radar. As I've already told you that it works on the principle of the Doppler shift, and in continuous wave radar, transmitter radiates the electromagnetic energy continuously. While what happened in the case of the pulse radar, that transmits pulses only. So here transmitter is continuously transmitting the EM energy, and transmitter signal are very strong, but when we are talking about the received signal from the target, that may be treated separately, and that particular signal will be weak. Here also you can observe that there is a single use of antenna. That is why a duplexer is being used. So single antenna is being used. So while transmitting, this antenna will be connected with the transmitter section, and while receiving, the antenna will be connected with the receiver section. So here transmitted radiates the continuous energy in the form of unmodulated sinusoidal oscillations at a frequency ft, right? And a common antenna that is used, and that is being like shown over here, and the duplexer is being used. So via this antenna, energy will be transmitted, and from this antenna it will be received. So energy will be transmitted and the reflected will be received from this particular antenna. So according to the movement of the target, the reflected energy frequency will vary. See, reflected energy frequency, how it is going to be vary? See, if the target is coming closing, then received energy will have a frequency ft plus fd. So this particular term will be what? ft plus fd. And if the target is moving away, then the received energy frequency, that will be ft minus fd. That is why you can see here we have written ft plus minus fd, depending upon the target is moving away or moving towards. Or you can say if the target is approaching to the radar, the frequency will increase, and if the target is moving away from the radar, the frequency will be decreased. So here you can see there is a use of the detector. The purpose of this detector or mixer is to multiply the received signals. What is the received signal? It may be ft plus fd or ft minus fd frequency, and multiplication with which? Multiplication with the transmitted signal ft. which is taken from the transmitter directly, and after this detector there is a use of Doppler filter. What happens over here? Detector will produce the difference in frequency which will be passed it on to the Doppler filter, and Doppler filter is nothing but it is a low pass filter, so it allows the frequency from the detector and reject the other frequencies. So you can see at the output of the Doppler filter what we are getting. We are getting the Doppler frequency, and here sign is not being indicated, right? So sign doesn't indicate it over here. It means we are going to identify the direction of, so on the basis, because you are going to observe like how the target is moving. So the output from Doppler filter, it can be further amplified up to a certain level depending upon the requirement, so that we can indicate over the frequency meter or wherever we require the display can be done. So depending upon the requirement, the output can be displayed and the data can be taken out for the further analysis. So these particular blocks which I have discussed over here, I have listed down in this particular table. The function of each and every block in detail I have mentioned over here, so you can take a review. Now let us discuss the another block diagram of continuous wave radar, which is the CW radar with IF amplification. Here you must be curious why IF amplification is required. See, you can see this particular block diagram where IF amplification, this particular unit is being taken over here. So the receiver which actually operates with a non-zero IF, and in this particular case a separate antenna, means transmitting antenna and the receiving antenna, two separate antennas have been used for the transmission and reception. There is a dedicated function for each and every antenna, and the noise generated in the crystal detector or in the case of vacuum tubes, that particular noise, it may impact or create the flicker effect, right? And the flicker effect, it actually varies as 1 upon f raised to the power alpha. Here alpha is approximately the unity, and the flicker noise which is actually formed in the case of the CW radar, this is required to be considered. Why it is required to be considered over here? Because this particular noise is generated at low frequency range, and CW radar, it also operates on low frequency range. That is why we cannot ignore this particular kind of noise. And to eliminate this noise in super heterodyne receiver, IF stage, which is the intermediate frequency stage, that IF stage must be used. So this is the actually function why it is being required to used in the case of the continuous wave radar. Now you can see in this particular block diagram, CW transmitter transmits the signal which is being transmitted from the transmitting antenna, and the reflected energy is being received from the received antenna, and at simultaneously a small portion of transmitter output, you can see FT, that is mixed with the output of a local oscillator, right? So what we are getting over here, FT plus FL. At the output of this mixer, we are getting FT plus FL, means it also receives the Doppler shifted. When we are talking about the receiving signal, receiving antenna, here whatever the signal is being transmitted, there will be certain shift in the frequency which is the Doppler shift, and the receiving antenna will process that particular energy. It means the received signal will have the Doppler shifted component from the antenna and producing an output difference frequency from the transmitted one, and the output of the mixer, that is being amplified and demodulated also. And the signal, now you can see at the receiver stage, here there is a detector. Detector is what? Detector, Doppler filter, and then there is a use of the display. So here you can observe the sign in the Doppler shift that is being lost at the output of the detector when we are getting at the output. So the received signal is being amplified, IF amplification is being done after passing through the second detector, it is being passed out, and here the sign is actually lost, it means it is not possible to tell whether the target is approaching or moving away. So the overall receiver system is actually similar to the super heterodyne receiver. The only thing is extra sensitivity is provided over here by the lowered noise. Right, and here there is one important factor, important problem actually which exists, the problem of isolation. The problem of isolation is the main determining factor, which is as a consequence of the continuous wave power from such a radar. Means actually it exceeds 100 watt and sometimes it is very less. So gun diode, impact diode, for highest power continuous wave, magnetrons are also used as power oscillators in the case of the transmitters. So you must remember which particular devices can be used. So the continuous wave radar can be used to measure the speed of automobiles, shells guided missiles, and it can also be used to detect movement of troops vehicles in dark, and even in the case of the bad weather situation also. And it can also be used as a radio proximity fuses. So these are various applications. So in this particular case, I have already told you what is the importance of IF amplification, and rest you will be able to explain the function of each and every block in this particular block diagram. And finally, after passing through the Doppler filter, which is a kind of low pass filter, whatever the required information that could be displayed on the radar display. There are various types of radar displays available, A scope, PPI scope. So anyone, depending upon the requirement, which type of data we need, the type of scope can be used. Thank you so much for watching this video.